Hello everybody. Today we will see the retrofitting structures. This is a civil engineering topic from the subject Advanced Construction Techniques and Equipment studied in 6th semester Diploma Engineering. Okay. Today we will discuss why retrofitting is required, what is a retrofitting, objectives of retrofitting of a structure, to retrofit or not to retrofit to a structure, retrofitting techniques, materials to be used in retrofitting, and critical remarks with the references. So, why retrofitting is required? So, starting from the term retrofitting, retro means old. Old structures which are nearly prone to destruction or which is very weak structure, the old structure. Retro, the meaning is retro. Fitting means to make it fit for the earthquake resistant construction, to make it fit for the ongoing modern civilization, to make it fit to resist the quakes, different quakes. So problems faced in concrete structures, why retrofit is required, what are the problems we'll having in the old structures. Damage to the structural members, it is a old structure, so damages are there. Excessive loading, errors in design or construction, uh, modification of structural system, seismic earthquake damages, structural cracks, corrosion due to penetration honeycombs. What is retrofitting? Now come to the point. What is retrofitting? Retrofitting is the seismic strengthening of existing structures, old structures, existing old structures, to make it strengthening, to make it strengthen to resist the seismic forces, earthquake forces. So retrofitting means old structure to make seismic strengthening the old structures. It is an improvement over the original strength when the evaluation of the building indicates that the strength available before the damage was insufficient and restoration alone will not be adequate in future quakes. So this is one of old structure, we are making it uh, giving it strength to resist the quakes. First of all, we are trying to make it restore. If the restoration of the structure will not sufficient to resist the earthquakes, then we will go for the selection of the technique called retrofit. What is the motto, objective of this retrofitting? Now, increasing the lateral strength in one direction or in both the directions x or y by reinforcement or by increasing the area, cross sectional area, application area, or the number of walls or columns. The second one is giving the total structure a unity to the structure by providing proper connection. So we will work here on the connections, on the cross sections, on the areas of cross sections. So when to retrofit? We'll go for retrofitting of a structure or will not go for a retrofitting of a structure. This is one graph in y-axis. This is one graph of seismic load capacity versus risk of building collapse. Seismic load or the earthquake load versus the building collapse risk. So we'll take the y-axis as the risk of collapse, take the x-axis as the existing strength as a fraction of capacity required by current standard for a new building in percentage. Now you see the percentage is increasing and the risk factor, collapse risk factor, is decreasing. So this region, you see this region in the red mark, in this region the risk, seismic risk factor from this to this region, we can go for the retrofit. Above this it is a waste, we cannot go for retrofit, it will be waste of time and money. Below this it is not required, standard risk. So to resist the earthquake, retrofitting is not required, only the restoration of the structure is sufficient to take the earthquake load. So now you see the retrofitting techniques. There are several retrofitting techniques. First of all is global retrofitting techniques, and the second one is local retrofitting techniques. The global means as a whole of a structure, so think that it is a building. If you are retrofitting the total building, then it will called be as a global retrofitting. Every components of the structure will be retrofitted. And if it is a local retrofitting technique, means only the particular component will be retrofit, like only the beam, only the column, only the wall. So this is called local retrofit. If we will make the whole retrofit, whole building, then it is global. So what are the different methods, techniques of global retrofitting? Now adding shear wall, adding infill wall, adding bracing, wall thickening, adding wing wall or buttress, mass reduction, supplement damping and base isolation. These are the, as a whole we are doing it. So global retrofitting. What is local retrofitting? Now only to the beams. So let's say we are strengthening the beams only, then jacketing of beams. We are strengthening the columns only, jacketing of the columns. We are strengthening the joints, then jacketing of the beam column joint. We are strengthening the footing, then strengthening the individual footings. So these are the different techniques we are following in the retrofitting. Okay. So now the first one is adding a shear wall. We are making here the global retrofitting. We are making every wall of the structure retrofitted, making it strengthened to sustain the earthquake shakes. So we are adding here the shear. Here you see in the figure we are adding an additional wall, additional shear wall, which is used for non-ductile reinforced concrete frame buildings. You think it is a stone building, old stone building made up of stone. A building made up of, the walls are made up of only the bricks. Then it is a non-ductile thing. We are adding reinforced shear walls, making it, giving it ductile properties to resist the shakes, earthquake shakes. A new shear wall can be cast in situ or precast concrete elements. A new wall will be added to the previously existing wall to give it ductility property. Then it can be placed at the exterior wall of a building. However, it may be caused in the appearance. Increase the, why we are giving the shear wall? Increasing the lateral strength, fast. We are increasing the lateral strength of the wall, we are increasing the ductility, we are stiffness of the building substantially enhanced. Okay. Now adding infill wall, adding inside wall. Infill means inside wall. This is a brick masonry infill wall. Some walls are broken, some walls are not there. We are providing the infill wall installed tight to surrounding concrete elements. As you see in the figure, we have another big figure also. The lateral stiffness of a story increases with infill wall. We are adding infill wall to extend this stiffness. Due to strut action of the infill walls, the flexural and shear forces and ductility demand on the ground story columns are substantially reduced. So this is your brick masonry infill wall retrofitting. This is the existing frame structure and we are providing the new brick wall, infill wall. The next technique is adding steel bracings. As you are seeing here, steel bracings. We are providing steel bracings to give extra support. An effective solution when large openings are required. Sometimes large openings are there in the old structures, we cannot replace it. We are giving those openings support by steel bracings. Opening for natural light add much less weight to the existing structures. We are providing these bracings with very less weight of the existing structure. The next technique is thickening of the wall thickening. Thickening of the wall. If there was the wall weak wall, we are adding another wall to it, making it thicker. Increase the thickness by adding bricks, concrete, steel reinforcement. As you see here, it can be bear more vertical and horizontal loads, does not cause sudden failure of the wall. You see, this is one wall thickening, reinforced concrete wall thickening technique. Then adding a wing wall or buttress wall, as you see, adding a support wall, adding a support. You are providing one extra wall as a support, wing wall. You see, to increase the lateral strength, ductility and stiffness of the structure. The wing wall are placed on the exterior side of an existing structural frame. Mass reduction. If the old existing structure is weak and having more mass, we can here make it stable, make it strengthen by reducing the mass of the structure. Here you see there are 4-storied building, we are reducing 1 story to make the mass less. We are reducing the mass here. In this process, to removing 1 story of the building to reduce the mass of the structure as shown here, decrease the load at the foundation, increases the life and strength of the structure. Then the next technique, global technique, is base isolation. Base means foundation. We are isolating the foundation from its footing. We are providing some arrangements, mechanical arrangements to make the base isolated from the ground. You see, I will show you the figure next. Isolation of superstructure from foundation is known as base isolation. From foundation, we are just making the superstructure and substructure different from each other, isolating the superstructure from the substructure. It is the most powerful tool for passive structural vibration control techniques. The structural vibration comes while the earthquake is there. The vibrations, the lateral vibrations will be observed by these techniques. Isolates the building from ground motion, lesser seismic loads, hence lesser damage to the structure, minimal repair of the superstructure. So the every observance of the vibration will be observed in the substructure only. Because the superstructure is isolated, the all total vibrations will not transfer to the superstructure from the substructure. Building can remain throughout the construction, does not involve major intrusion upon existing superstructure. Here you see this is a fixed base building and this is a isolated base building. You see base isolation bearings given here and here. Now after ground movement, when the earthquake is there is ground movement. After ground movement you see this fixed base building will directly impacted from this base to the top, directly impacted. Directly impacted. But in the base isolation of the base holds the observes the ground motion, the substructure observes the ground motion and the superstructure is as usual, no vibration to the superstructure. Now coming to the local retrofitting techniques, here we local means particular components of a building, whole building, particular components are to be treated for retrofitting. So jacketing of structural elements, we can jacket the column, we can jacket the beam, so we can jacket the beam column junctions. So this is the most popular method for strengthening of concrete building elements of beams, columns, beam column joints. What is jacketing? Jacketing means adding extra layer as a jacket you wore while it is cold, like to make it strengthen we are putting one extra layer on the column or beam. Due to jacketing enhancing the shear strength, concrete confinement, flexural strength. Materials to be used: steel plates, fiber reinforced polymer wrap, carbon fiber reinforced polymer wrap, glass fiber reinforced polymer, steel reinforced concrete. So these are the materials to be used for jacketing purposes. You see retrofitting at junction by steel plate. This is one we are providing steel plates and we are jacketing here by providing reinforcement. We are wrapping here, we are wrapping the column by the carbon fiber wraps, polymers. We are wrapping the column and saving it from the corrosion, etc. Here you see the wrap available. We are wrapping here the old columns and beams, making it strengthen. You see retrofitting by steel reinforced concrete. We are adding another layer of RCC to the columns, to the beams, to the roof as a whole, making it strengthen. So critical remarks. What retrofitting technique does to the existing old structures? It increases the capacities. What capacities? Its strength, stiffness, ductility, stability and integrity of the concrete structure. The reduction in loss of lives, damage of the essential facilities, and functional continuity of lifespan of the structure, decrease the working space of concrete structure due to extension in structural elements and affect the appearance. It increases in lateral stiffness with high shear concentration near wall, increases in overturning moment at foundation. So references, these are the references we have followed here to prepare this retrofitting technique PowerPoint slide. So thank you all. Have a very great day, very great year ahead. Thank you so much.